How does quantum superposition work with wave-particle duality? Imagine a tiny particle like an electron or a photon. It can act like a wave or a particle depending on how you look at it. That's what wave-particle duality is all about. When particles go through a double-slit experiment, they create interference patterns like waves do. But if you measure where they land, they show up as individual particles. It's as if they have two personalities, switching between wave and particle depending on observation. Now, quantum superposition is a way to explain how particles can be in multiple states at once before you look at them. Instead of being in one specific place or state, their behavior is described by a wave function. Think of the wave function as a recipe that combines all possible states a particle can be in. When an electron passes through the double slits, its wave function spreads out and goes through both slits at the same time. This is superposition. The wave function from both paths overlaps and interferes, creating the interference pattern we see on the screen. This superposition is what makes particles behave like waves. They are not just in one spot but spread out in a range of possibilities. When you finally measure where the particle hits, the wave function collapses. It chooses one specific position, and the particle acts like a tiny ball hitting the screen. Until that moment, the particle's wave-like nature and superposition govern its behavior, allowing it to interfere with itself. Wave-particle duality shows us that particles are not just particles or waves but can do both. Superposition explains how they can be in many states at once, like passing through both slits simultaneously. The wave function is the key to understanding this. It embodies the wave aspect, and measurement reveals the particle aspect by collapsing the superposition. These ideas are the foundation of many quantum technologies, like quantum computers that use superposition to process multiple possibilities at once. They also help us develop advanced sensors that use the wave nature of particles to detect things with incredible precision. So, in simple terms, superposition lets particles be in many places or states at once, and wave-particle duality shows that particles can act like waves or tiny balls depending on how we observe them. Together, these principles explain some of the strangest and most fascinating behaviors in the quantum world.